Alright, so we're going to talk about factoring. Two types today. First is the greatest common factor. The greatest common factor is the largest number and or letter that can be undistributed from a polynomial. So we are doing distributive property in reverse. We're looking for what did they distribute in, and we'll know that because it's in every piece. Remember, what you distribute comes to each piece. So we're looking to figure out what can we take out and put out here, and then what was used to be in the parentheses before we distributed. So the greatest common factor, GCF for short, we're looking for what number can we divide 6 and 18 by? Well, we can divide them by 2. Is there anything bigger? 3. 6. 6 is the biggest. So let's divide them both by 6. Undistribute the 6. And then we have to look at the x's. The first term has 3 x's. The second term has 4 x's. So the amount of x's they both share was what was distributed. They have a minimum of 3 apiece, so they must have distributed x to the third. So what do we have left? If we have a 6x to the third and we pull out a 6x to the third, 6x to the third divided by itself equals 1. Anything divided by itself equals 1. If we have a negative 18 and we divide by a 6, we have a negative 3. And if we add x to the fourth and we divide out an x to the third, we remove 3 x's, we have a single x left. And that is the distributive property problem that created this. Alright, what about this longer trinomial here? Again, find the number that all 3 pieces can divide by, if there is one. There's not always one. But all of these are even numbers, so all of them could divide by 2. I would think that there would be something bigger because of the 90 and the 12, but not with a 2. 2 is as big as you can go. So we're going to pull out a 2. And then we're going to look at the x's. We have an x to the fourth, an x to the third, an x squared. So I can take a minimum of 2 x's out of each term. So this time 2 divided by 2 is 1. X to the fourth, remove x squared, I'll leave x squared. Remember, dividing with powers is the same as subtracting the exponents. Negative 90 divided by 2 is negative 45, leave that. X cubed, take out an x squared, leaves an x. Negative 12 divided by 2 is a negative 6. We removed both x's, so just 6. Alright, so greatest common factor is always the first thing you want to look for in every single factoring problem we do. So always look to see if there's something you can divide. Okay, after you've looked for your greatest common factor, here's another strategy to try. Focus lock there, see if that'll quit fuzzing on you. There we go. When you have 3 pieces and a equals 1, meaning this first piece right here is a 1, so it looks like x squared plus a number x plus a number. You don't see anything in front of that x squared. Then we would unfoil that. Foil, remember, is what it's going to look like when you have 2 parentheses. So that's going to be what it's going to look like this time. I'll put that up here because I'm about to erase it down here to write the notes. Okay, when we're foiling, we're distributing twice. We're taking whatever's first and multiplying it by both of these pieces. And then we're taking whatever's second and multiplying it by both those pieces again. And so the 2 numbers we pick to go here have to multiply together to make this number. We find 2 numbers that can multiply to C. And then when we add their like terms, because we're going to have a number here and a number here, we're going to add those like terms. They're going to add up to this B. So we need to find 2 numbers that can multiply to equal this last number and add up to equal this middle number, and they will be the 2 numbers we put in our parentheses. So let's try it out. I have 4 problems for us. So I need to find problems that multiply to 19, a pair of numbers that can multiply to 18, I said that wrong, and can add up to be 9.
Tories, please call 32444. Brenda Tories, please call 32444.
Okay, sorry for the interruption. So these are the pair of numbers that multiply to 18. And I'm looking for which one of those pairs can add up to be 9. And I think it's pretty obvious that it's the 3 and the 6. So I need to place an x times an x to get my x squared as the first piece when I'm multiplying. And I need to place my plus 3 and my plus 6. So when I do the outside part of FOIL, I get 6x. The inside part of FOIL, I get 3x. So that adds up to 9x.
Because of our short week, we will be on an A block today, B block with advisories tomorrow, and B block with 0
let's try this
hour
one.
on Wednesday. Again, we are on an A block, 0 hour schedule today.
I need numbers that multiply to negative 20.
The auditorium if they are in the building.
So we have 1 times 20, 2 times 10, 4 times 5. Now this time, since 1 needs to be negative, I will think of placing the negative with either the 1 or the 20, the 2 or the 10, the 4 or the 5. Not both, just 1. A positive times a negative makes a negative. So this time I want them to add up to be negative 1. So the only two numbers close enough to do are that, the 4 and the 5. So it's either negative 4 with positive 5, or it's positive 4 with negative 5. So which one of these will it be? If I add these up, I get 1. Not quite. If I add these up, I get negative 1. That's the one I want. So the x squared will be x times x. And then one parentheses has a plus 4, the other one has a subtract 5. Okay, let's try 2 more, and hopefully we won't get any announcement interruptions. Okay, so we need numbers that multiply to positive 12 and add to negative 7. So x and x get our x squared every single time. Let's see, 1 times 12, 2 times 6, 3 times 4, those are the factors of 12. Now how are we going to get two numbers that multiply to positive and add up to a negative? Must be because we have a double negative. Negative times negative multiplies to positive, right? But would add to be negative still. So if I put negatives in front of all of those and find out which pair adds up to negative 7, that's this pair right here. So negative 3, negative 4. There is no right answer, by the way, to which one goes in the first parentheses, so x minus 4 and x minus 3 would have been great as well. Alright, now this final one looks super scary, right? And hey, what happened to there being a 1 in the front? Remember, always look for what is the greatest common factor. All of these pairs of numbers can divide by 3, can't they? So what if I factor out a greatest common factor and leave myself an x squared? 39 divided by 3 is 13x, and 36 divided by 3 is 12. Can I then unfoil x squared plus 13x plus 12? Keep this coming down. Can I get two numbers that multiply to 12 and add up to 13? I can try. Let's see, 1 and 12 again, 2 and 6 again, 3 and 4 again. This time everything's positive, so all of my factors will be positive. So hey there, 1 and 12 plus 1 plus 12 multiplied to that. Alright, we're going to call that stop.